Okay, in this video we're going to start talking about exponents, and let's consider if we had something like a times a times a times a times a, where a is just some number. Well, instead of writing a out 5 different times, it's a lot easier if we just call this a to the 5th power. The 5 in the power of a is called the exponent, and the thing that's being raised to the power is always going to be called the base. Well, let's look at a to the 3rd power, which we also call a cubed, times a to the 4th power. Well, if you wanted to write out what this means, the a cubed means a times a times a, and the a to the 4th power means a times a times a times a. That leaves us, of course, if you count it up, with a to the 7th power. And you might notice right off the bat that the 3rd power and the 4th power on a add up to 7. And that's not a coincidence. You could do this any number of times, and you'd always notice that the 2 powers here are going to add up to that power right there. So you can actually come up with this general rule. And the general rule says that a to some power times a to some other power is equal to a to those 2 powers added together. That might look a little bit scary with the a and the n and the m floating around, but it's really not too bad. A can be any number or variable. The same is true for n and m. So an example of this might be x to the 5th power times x to the 10th power. We know that that's going to be equal to x to the 15th power because 5 plus 10 adds up to 15. I'm actually going to start a list of rules over here on the right, and let's take a look at another example. Let's say we have a to the 7th divided by a cubed. Well, what that looks like is a times a times a times a times a times a times a. I think that's 7 of them there. We're going to divide that by 3, a times a times a. That's what a to the 7th divided by a cubed means. Well, as you know, you can cancel the same thing from the numerator and the denominator. As long as everything is multiplied here, we can cancel 1a from the numerator and the denominator. You can actually do that 2 more times. That leaves us with just a times a times a times a. It leaves us with 4 of them, or a to the 4th. Well, you might notice that we started with 7 a's multiplied in the numerator, and we got to cancel out 3 of them because of the 3 in the denominator. What that did to our powers is it actually subtracted 7 minus 3, and it gave us 4. So you could do this over and over and over again, and you'd always notice that if you had a to some power divided by a to some other power, you're always going to end up subtracting those 2 powers. You're going to end up getting a to the m minus n power. And that's another one of our general rules. Just as a real quick example, let's say we have y to the 23rd power divided by y to the 7th power. All we have to do to figure out what that is, to simplify it, is to subtract 23 minus 7, and that is y to the 16th power. Alright, let's put that in our list of rules and move on to the next one. For our next rule, let's say we have a to the 4th, and that whole a to the 4th is to the 3rd power. Now, just a quick note, you may be wondering why I keep using a. There's no reason to use a. It's the first letter in the alphabet, I guess. We could be using b or c or x or any number, really. The other thing I want to point out is that these rules actually only work if your bases are the same. So as a really quick example, if you had x squared times y cubed, there's nothing you can do to that. You can't combine these 2 things because they have different bases. Okay, let's keep going. A to the 4th cubed. Now what that means is we have a to the 4th, which is a times a times a times a. And if you cube that, that means you have to multiply it out 3 times. So what we have is a times a times a times a multiplied out 3 times. That's a to the 4th raised to the 3rd power. Okay, well, how many a's is that? You can count it up, or you might be able to tell right off the bat that you have 4 things 3 times, which is just multiplication. you have 12 of them. And you might think right off the bat that the general rule here is going to be if you have a to some power raised to another power, all you really have to do to get your answer is multiply two powers. That's a to the m times n power. That's going to go on our list of general rules, and as a really quick example, let's take z to the 6th power to the 5th power. Well, z to the 6th, all that raised to the 5th power is just z to the 30th. And you get that 30 by multiplying 6 times 5. Okay, so far we have 3 rules. We have the product rule, the quotient rule, and the power rule. I want to look at one specific example of this quotient rule. Let's say we have a to the 6th divided by a to the 6th. Well, the quotient rule says that we should end up with a to the 6 minus 6 power, which of course is just a to the 0 power. Well, let's look back at the very first line. A to the 6th divided by a to the 6th. Those should just cancel out. Everything cancels from the numerator and the denominator. And when everything cancels from the numerator and the denominator, you're just left with 1. So we know that the answer is going to be 1. And we got, using the quotient rule, that that is a to the 0. So what we just found using the quotient rule is that really anything to the 0 power equals 1, because a can be anything. So we're going to add that to our list of rules. And I should make a note that in this case, a can't be 0. We don't consider in this class what 0 to the 0 power actually is. Now, a couple more quick rules. If we consider two different bases to a single power, let's say we have a and b raised to the 3rd power, we can separately raise a and b to the 3rd power. Now this works because a and b are multiplied here. If a and b were added, we couldn't actually do this. So the general rule that I'm just going to write down in the rule list is a times b to the m power is just going to be a to the m times b to the m. And just a really quick example of that, let's say we have 2x raised to the 3rd power. In that case, we have to raise 2 to the 3rd power as well as x to the 3rd power. 2 to the 3rd power is 2 times 2 times 2, which we know is 8. And x to the 3rd power we just have to leave there. Call it 8x cubed. And the last rule that we're going to talk about in this video involves two different bases. We'll call them a and b, and they're divided, and they're both raised to the same power. Well, this is pretty simple as well. We can separately raise a to the 5th power and b to the 5th power in this example. And the general rule that we end up getting is a divided by b raised to some power is a to that power divided by b to that power. So that is our complete list of rules for this video. Let's just do a couple of quick examples and then we'll set you up with a quiz. Okay, as our first quick example, let's look at a squared times b, that whole thing raised to the 5th power. What we can do is use this rule right here, which means we're going to raise a squared to the 5th power, and we're also going to raise b to the 5th power. Well, we already know what a squared to the 5th power is from this rule right here. A squared to the 5th power means a to the 10th power, because we can just multiply 2 and 5. And then b to the 5th power just stays b to the 5th power. This example down below is x plus y to the 6th power divided by x plus y squared. Now luckily, we have the same base. In both of these cases, the base is x plus y. So we can use the quotient rule, which just says all we have to do is subtract 6 minus 2, and we get x plus y to the 4th power. Now it's very tempting to just say that this is x to the 4th plus y to the 4th. Unfortunately, that is not the case. We cannot do x to the 4th plus y to the 4th. That actually gets a little frowny face. If we were going to write out what x plus y to the 4th power is, what we'd have to do is we'd have to do x plus y times x plus y times x plus y times x plus y. And that's just too much work. That takes too long. So we're just going to leave the answer as x plus y to the 4th. Let's look at 12r to the 10th s to the 8th divided by 4r to the 5th s squared. Now we're going to divide this into three different parts. 12 divided by 4. We can do 12 divided by 4. We know that that's just 3. Now we want to look at the r terms. We want to look at the two terms that have r as their base. We know that we can combine those two because they have the same base. And the rule that we're going to use is just the quotient rule. R to the 10th divided by r to the 5th, you just subtract 10 minus 5, and you get r to the 5th power. Now we're going to look at the s terms, the two terms that have s as their base. Again, we can use the quotient rule. S to the 8th divided by s squared is just s to the 8th minus 2, which is s to the 6th power. We get a very colorful looking answer there. Just to make it look a little bit more solid, I'll copy it down and box it up. That's our simplified answer. Okay, it's time for your video quiz. Simplify these two as much as possible. Use the rules that we wrote down and see what you can do. See you in class.